Now we will look at lesson 18 again in section 8.3, and we're going to look at this question. It doesn't have the question number, but the question is, can you plot this complex number on the complex plane and write it in polar form and in exponential form? So to plot the complex number z equals x plus yi, plot the corresponding ordered pair in the same way that a point is plotted on the rectangular coordinate system xy plane, using the x-axis as the real axis and y-axis as the imaginary axis. So on this complex number, -3 is the real part, x value, 10 is the y value, that's the imaginary part. So here under the drop-down menu, we're gonna need x, y, 2 points, and then this is what we need to check first if we want them in x comma y order. Now, for this complex number, -3 plus 10i, we're going to write an ordered pair to determine the rectangular coordinates. So the x value is -3 and the y value is 10. So this is the point I need for this question, and check my answer. Now, to plot this point, we're going to move 3 units to the left because -3 means left on the real axis, and 10 units up because positive above the parallel to the imaginary axis. So -3. Now it's time to graph this. Follow the path given in the previous step and plot the point. So this yellow dot, I need to move this to -3 on the x value, but then 10 on the y value. So this is 10, and that's a negative. See, this is not 10, so I'm just going to move it a little bit more. Now it's at 10, and the x value is -3, and I'm going to check. And this is how we plot a point on the coordinate system. Which quadrant does the point lie? So as you know, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So the one that I have x value is negative, y value is positive, is in quadrant 2. So we're going to choose quadrant 2. Now, if r is greater than or equal to 0, and the angle is between 0 and 2 pi, the complex number z equals x plus yi may be written in polar form as, so the polar form is always r times cosine of theta plus I sine of theta. So we have to memorize these rules, and this is always the polar form, r times cosine of theta plus I sine of theta. Now, we want to find the r value for this. So r is the distance from the origin to this point. So we're going to square -3, the x value, and 10, which is the y value. This is a 100, this is a 9. So I will need square root of 109 here. Now, we're going to find the angle associated with this complex number. So for the angle, we need to find the cosine value and sine value to decide what angle we need. So cosine of theta is x over r. So here, x value in this problem was -3, so I will need a -3 here. And r value is something I calculated. So I don't know if they will ask me to rationalize it right away, but I want to try my chance like this. And then the sine value is y over r, where y value is 10, and r value is square root of 109. And then when I check my answer, it says that you got the both cosine and sine value right. Now this part, this is not a very famous angle that I can find the angle without a calculator. So the angle satisfies the both equation. So remember, this angle is in quadrant 2. So we're gonna have to give them the theta. So since this is not a famous angle, I'm gonna go to Desmos here. And then we're gonna open the graphing calculator, and I will ask Desmos, who is the angle, who is the cosine value is -3 over square root of 9. And the way I ask this question is cosine to the power of -1, which is our cosine. So you can just simply write our cosine. And then the cosine value I had in this question was it 3? Was it 3? It's -3 over square root of 109. So square root of 109. And then it has me the answer in radians. which is 1.86. Now, pi over 2, because pi over 2 is right here. So if we change pi over 2 to a decimal number, which is 1.5, so this is already in the second quadrant, so I don't have to go through the thinking process for the second quadrant variation. So it's 1.86. So let's go back to homework. It says round to the 3 decimal places as needed. So I need to give them 1.862. 1.862. This is how I express the angle. And then when we check this, they tell me that we got the angle right. Now we're going to write this complex number in polar form with this theta and with this r value. So this is the rectangular form. 3 plus 10i is the rectangular form. Square root of 109 times cosine of 1.862 and plus I sine 1.862 is called the polar form. Now we're going to convert this to an exponential form. And here we just have to keep in mind that our value is here, square root of 109, and the angle is 1.862. When a complex number is written in the form of z equals r times e to the power of I theta, this is called the exponential form. Now, in order to convert this to the exponential form, we need the r value, which is square root of 109, e to the power of I, and then the theta that we got from the calculator is right here. And then, therefore, this will be the exponential form of the given question. Square root of 109, e to the power of 5, 1.862. So if we summarize what we're trying to understand with this question, this is a complex number, negative 3 plus 10i. And here the complex number is expressed in rectangular form. When you do a bunch of operations, like finding the r value and finding the theta, you can convert this complex number to the polar form, and the polar form of the number will be square root of 109 times cosine of 1.862 plus I sine 1.862. Now, you can also convert this to an exponential form where the formula is r times e to the power of I theta, and this is the r value, this is the theta value. So this question, this complex number can be expressed as square root of 109 e to the power of I 1.862 as an exponential form.